All right, so g is this function. Um, so it's a piecewise function. So from 1 to 2, it's going to be it's like a downward parabola. And then from 2 to 4, it's going to be a square root function. So part A, we're going to write the equation for the line that's tangent to the graph of g at x equals 3. So since it's at x equals 3, we're going to be looking at this expression. So we're going to have that g prime of x will be the derivative of the square root of 2x minus 4. So we take so this is the same as like 2x minus 4 to the 1/2. So we're going to use power rule combined with chain rule. So we're going to have 1/2 times 2x minus 4, take away 1 from that power, so then negative 1/2, times the derivative of the inside, times the derivative of 2x minus 4, which is just going to be 2. Simplifying this, the 2's will cancel on the outside, and we'll just get 1 over the square root of 2x minus 4. So this, remember, will give us our slope. So we're going to find the slope at 3. So g prime of 3 will be 1 over the square root of 2 times 3 minus 4. So 1 over the square root of 2. And so then we can start writing our equation for our tangent line as y equals 1 over root 2 times x plus b. So we need to find our y-intercept. For that, we're going to find the y value for when x is 3. So we're going to plug in 3 into this equation. So g of 3 is the square root of 2 times 3 minus 4, the square root of 2. And so that means that this will have the points 3 comma root 2, and we can use that to solve for b. So we're going to have root 2 being equal to 1 over root 2 times 3 plus b. And so then b will simply be root 2 minus 3 over root 2. So we can then write our equation as y equal to 1 over root 2 times x plus this whole thing, plus root 2 minus 3 over root 2. Now, you can rationalize it if you like, but I wouldn't spend too much time on it, especially if you're doing your exam. So let's look at part B now. Is g continuous at x equals 2? Use the definition of continuity to explain your answer. Okay, so for it to be continuous at x equals 2, that means the left-hand limit have to be equal to the right-hand limit at 2. So what that means is that the limit, how we write that, the limit as x approaches 2 from the negative side of g of x, that needs to be equal to the limit as x approaches 2 from the positive side of g of x. So if we're coming from the left side, we're going to plug 2 into here. So this will be negative 2 squared, so negative 4 plus 8. So we'll get 4. And if we were coming from the right side, we would plug 2 into here. Again, this is not saying that g of 2 is equal to, the square root of 2, the square root of 0, I guess. This is just what would happen if we were going to try to test this out. That would be the square root of 0, or 0. Now these are obviously not equal. 4 is not equal to 0. And so then the limit, or the g of x is not continuous at x equals 2. So no, because these values are not equal. Now, like to, kind of elaborate more about this. On a graph, it's easy to see. So, we don't have a graph, but if we did have a graph, this is what this would actually look like. Let's have this will be the line. How about x equals 2? That'll be the line x equals 2. On the left side, this is a parabola that actually has its vertex, I believe, at 2. So on the left side, it's doing something like this. On the right side, though, this thing is actually going as a square root function coming from the origin. Not origin, I mean actually the line x equals 2 or 2, 0, so it actually looks something like this. So you can see, like, if we're coming from the left, we're going to go to 4, and if we're coming from the right, we're going to go to 0. So then you can see easily on a graph that these graphs are not continuous. Remember, this is just an imaginary line I put. This is just the line to kind of show you a visual of what's going on there. So then that's just to give you an idea of what that means to be continuous. All right, part C, find average value of g of x from 1 to 4. Okay, so that's basically just integrating this function and then dividing it by 4. Or then dividing it by 3, because the difference from 4 to 1 is 3. So let me set this up. So we're going to integrate this separately since this is not continuous at 2. So we're going to have an integral from 1 to 2 of negative x squared plus 4x dx. And then we're going to add it to the integral from 2 to 4 of the square root of 2x minus 4 dx. After we get this value, we're going to then multiply by 1/3. Okay, so let's break this up one at a time. So this will be pretty simple because you just use reverse power rule. So we'll have the antiderivative being negative x cubed over 3 plus 4x squared over 2. 4x squared over 2, so 4 over 2 will then be just 2x squared. And we're going to go from 1 to 2. Plus, this one's not so straightforward because we're going to use u substitution. We're going to make u equal to 2x minus 4. And then du will be 2 dx. And we don't have that, but we have dx. So we'll have 1/2 du being equal to dx. And so here then we get 1/2 times the square root of u, or u to the 1/2, du. And remember, these endpoints are in terms of x. So so that we don't have to switch back to x when we integrate, let's just rewrite these new endpoints in terms of u. So using this, we're going to find what u is when x is 2 and x is 4. When x is 2, u is 2 times 2 minus 4, u is 0. So then in place of 2, we're going to put 0. And when x is 4, u is 2 times 4, 8 minus 4, and u is 4. So that actually ends up being the same thing. So then we just integrate this. So let's go ahead, let's finish this part first. Or together, I guess. we're going to have negative 2 to the 3, so negative 8 over 3 plus 2 times 2 squares plus 2 times 4 plus 8 minus negative 1/3 plus something that's plus 2. This is supposed to be the easy part, but it can be tedious, so gotta be careful. So then negative 8/3 let's change them all to like 24 third, and that'll be 6/3, so negative 8 plus 24. So 16/3 minus negative 1/3 plus 6/3 minus 5/3. We'll get 11/3 there. Hopefully it didn't mess up. Let's move on to this part now. Integrating this, of 1/2 u to 3/2 over 3/2 from 0 to 4. This basically just becomes 2's cancel, so it becomes 1/3 u to the 3/2 from 0 to 4 plus 1/3 u to the 3/2, so 4 to the 3/2, so 4 to the 2, so 4 to the 3/2 is essentially 4 times the square root of 4, so 4 times 2, so 1/3 times 8. And the 0 doesn't matter because it's just 0 minus 1/3 is negative 0. And so we have 11/3 plus 8/3. We have 19/3. Now, let's be careful because we're trying to find average value from 1 to 4. So then we're just going to multiply this by 1 over 4 minus 1, or 1/3. So 1/3 times 19/3, and we'll get 19/9 as our answer. And that's all there is to it.